Hey everyone, this is our follow-up to electronic ignitions, because when we last left, this is an aftermarket one, but it's still a Chrysler electronic ignition was king of, well, the ignition world. It came out first, and it totally revolutionized the way that cars were tuned, because now you didn't have to do maintenance on your car, well, very often, because this would literally lengthen the time between changing spark plugs, wires, caps, and rotors for 2 to 3 times what points would be. But I'm going to address some things from the comments because some of them are really fascinating, some were very good, and they never disappoint. One thing I did learn is that people with Fords would use this box, and there is here's a schematic from Woodchuck Workshop showing how to use this box with a Ford electronic ignition system, the DuraSpark 1, which isn't very good, and have this instead so you'd actually have a good electronic ignition. The other thing is on the boxes, that I saw a lot of comments on them, especially about this on the back. This is the rubberized sealer to keep moisture from touching the electronics. This melts because, and it mainly melted on the 5-pin, because the 5-pin had a separate power line in through the ballast resistor that separately powered this unit. They went to 4-pin to eliminate that, because that is what would cause these things to overheat and short, and this will melt. I've had 2 of the old style boxes melt on me and went down my firewall. Cleaning this stuff off is pretty nasty, but that is what happens to these boxes. They short out internally. This is actually a good orange box made in USA, unlike the new Chinese ones, which really don't work well. That's a whole nother story though. And and then the other thing was a kind of function of points. There were comments, and yes, I kind of went really high end, didn't explain the exact way they work, but that really wasn't the point of it. Basically, the point of explaining what points did at a high level was showing that they really needed to be, well, replaced, because they were not a good long-term solution, especially as cars matured into the modern age of the late 60s, early 70s. So I just kind of glossed through it because it literally wasn't the focus of the video. The video was actually how they tried to make electronic ignitions work. Now, and the last thing is, I do a lot of stuff on historical automotive things, because you need to understand why things happen, not just that they did happen or how things work, but why. Because it makes more sense when you know the why, like why Chrysler went and developed this, and why, what I'm going to talk about in this is the HEI system from General Motors, why that was done, because it's actually very pertinent to the functionality of it and how things were developed. So now we're going to be talking about the Malaise Era. Yes, the era from like 1974 to probably 81, 82. This was a really bad time for cars. Not as bad as now. Now is probably the worst time ever, but this was a really bad time. And because we're talking about that time in electronic ignitions, we're not going to talk about Ford, because Ford systems in the 70s were bad. I mean, they're pretty much no different than the Chrysler system, except they weren't as good. And that's just my opinion on them. DuraSpark 1 and DuraSpark 2 were really not Ford's best work. And we're going to talk more about Ford, because there will be a third video in the more computerized age, because that's where Ford truly shined. And I owned a few of those cars, and I was quite impressed by how Ford modernized quickly from being dead last to actually having great computer systems. So I always want to hear your comments, obviously, because I just retorted to them, and I do respond to them. Just try to keep them civil and constructive. That's all I ask. I know you're not going to, but I can always ask. And so comment below. And I always, oh, that hurt. I always appreciate them. So because we're talking, let us start off now with Chrysler. Well, Chrysler had the electronic ignition, but then they realized in 1974, 73, 74, that the government was going to change the rules for emissions control on cars. And because of this, they had to figure out a new system to replace the one that they had. Now, the one that they had, this system, was patented in 1973. The patent was filed in 1971, and it was designed by William Kessels, and this is addressing another comment, who worked in Michigan. And I'm going to show the patent here. He worked in Michigan at their engineering headquarters. He was a lifelong engineer for Chrysler. The electronic ignition was not developed in Kentucky, Texas, Zimbabwe. It was done in Michigan. That is where it was done internally by Chrysler. No, but it wasn't done with NASA or anything. It was Chrysler's invention. So, with that being said, for the follow-up, Kissels did have some input, but actually the person that was credited with the Lean Burn system was Gordon Fenn. So, this was released in 1975 on the 400s. 404 barrels with thermoquads. That was the carburetor. So Fenn came up with a system called the Lean Burn, as I said. Now, it got rid of this module, and it went and put this module on. Yeah. So it was a little computer, analog computer, that read water temperature, throttle position, air temperature, and the rate of change of the throttle. And it put all that in there, and it adjusted the timing, and it adjusted the carburetor. That's why those carburetors from 75 and up on thermoquads have all those little things on the outside and the vacuum ports. It's because the Lean Burn system was modifying them to match the timing to give a 18-to-1 air to fuel ratio instead of the natural balanced 14.7-to-1 air to fuel ratio, hence Lean Burn. Now, the system actually was really well designed. In 1975 on that 400, it made all the emissions that the government had asked from the car companies. Everybody else had put catalytic converters on their car except Chrysler on the 400 with the new Lean Burn system. Unfortunately, in 1976, there was a new goalpost made by the government, and they had to put catalytic converters on all the cars. But the system actually worked very well for the catalytic converters and actually kept them from clogging and having other issues because it was running lean, which makes the converter actually more efficient. Now, not everything was rosy with this system, though, and there's a reason it has the reputation it does. One of the major problems of this system was that, as you see in this picture right here, it's mounted on the air cleaner. Yeah, not a great place to put it because it's kind of hot underneath there. Oh, yeah, and it shakes. These are two things that computers, no matter what type they are, do not like. So the system used to have problems where the soldering would come apart from heat and vibration. And so then the system would start not working properly, and the engine would run really, really bad. It wouldn't be able to time itself, and it wouldn't be able to set its mixture. It was not a good thing. The other part of it was that testing on this was really rudimentary. You really didn't have any way to make sure that this system was working properly. You could check all the vacuum lines. You could check in the impedance on the individual sensors. You could do all these things, but you really ended up having more of a shotgun repair approach, which means you just kept on changing this piece or that piece or this piece or that piece until you actually fixed the car. It really made it very difficult to actually have the car work right. And of course, this is during when Chrysler was near broke. So a lot of the factors that made this system not work well were because of lack of money, hence having the computer mounted on the air cleaner, because they wanted to run the least amount of wire humanly possible, and that was the closest place they could do it. Heat shielding really wasn't what it was now. Back then, it just wasn't. So what's even worse about this hot mess of a system is that Chrysler used it till 1989 on the V8s and the slants. Until the end of the slants and until the end of like the legacy 318s, 360s, they used this horrible system, and it made those cars in the V8s in those 80s horrible. They were so far behind at this point. And when we get to the third installment, which I am going to do, you're going to see how bad their system was compared to everybody else's. So the funny thing is that Chrysler had stumbled onto the secret sauce that was later used in fuel-injected cars. See, my BMW here, my 89, it is an early fuel-injected car. And the thing is, it uses the same inputs that Chrysler had developed on that lean burn system, plus airflow. It uses a mass airflow sensor to calculate how much air is coming in. And pretty much Chrysler was too far ahead of the curve with this system. And because they were trying to do this with a carburetor and not fuel injection, and because they put the computer inside the engine compartment, not inside the car like the BMW's is, it really made it a failure because it was too far advanced and not good for practical use. So honestly, once again, the engineering company out-engineered themselves and made something that is considered one of the worst ignition systems, well, just engine management systems ever made. So let's move on to GM, because GM in the 70s with their ignition system honestly revolutionized it. They came into it late. It was 1975 before they came out. They're the last ones. But they came out with the high energy ignition, the HEI. Now, this was developed by Remy Delco. They were the in-house GM unit that GM had bought like a decade and a half before. And they were trying for years, as you see in my previous video here, to make a system to get rid of points. Now, the thing was, GM was looking for this not to make a better running car per se, or to make more power. No, see, General Motors was doing something that General Motors needed to do. They needed to actually have cars come in less for warranty work during the first year. Remember, General Motors is the largest manufacturer in the world at this time. So think about it. All the cars that they made with points, you have a good chance in that first 12 months, 12,000 miles, which was the warranty back then, of something very not good happening with those points, and then having to come in and do repair work on the car. Well, by doing this system, General Motors figured they would actually be able to cut how many times those cars would come in the first year. See, now the other benefit of the HEI system was that it created a hot spark, a much hotter spark, because instead of using 8 volts, which is what the Chrysler system uses because of the ballast, and Ford pretty much used the same because it used a resistance wire, this system had full 12 volts sent to it. Now, full 12 volts doesn't sound like 4 volts difference, but when you amplify it in a coil, because that's what a coil does, it amplifies the power. These systems were putting out over 40,000 volts constantly. No matter what the RPM was, no matter what the load was, it put 40,000 volts into the ignition system. While Chrysler could vary anywhere from 8,000 to 30,000. Due to heat and all these other factors. So in 1975, when they came out this, Chrysler had switched to lean burn, and General Motors put catalytic converters on and had this hot ignition system and was able to make emissions control. They did some carburetor stuff, but there was mainly this incredible ignition that had complete burn because it burnt such a hot spark. Now, the thing is about this HEI system that makes it so incredible is that it was able to be scaled to move on with computer control, which was the computer commands control system in 1981. They still were able to use the same distributor because it had the modules on the inside of it. And so because this system was so well thought out and scalable, General Motors was able to use this on everything from 4 cylinders, 6 cylinders, and 8 cylinders of any size. Now, the thing is, it had a module on the inside that could be changed for the type of car and the type of application, which made it very easy to go from car to car to car. Also, on the V8s, the coil was everything was all in one little package. So the coil was on top, and you had your module on the inside, and the cap was gigantic because of the hotter spark. On V6 and 4s, and the inline 4s, the coil had to be separately mounted because there wasn't enough room in that cap. Even though the cap was bigger than average, it was still too small for the coil. Now, not everything is rosy with this HEI system because there's a couple things that can happen. First of all, that module is buried inside the distributor. Now, they did put heat paste on there like you have on your computer, which the heat sink paste. Well, over time, it dries out, especially in that type of environment. And then the module overheats and stops working. I mean, fixing it is not a big deal, but you have to take the cap off, take the rotor off, and go in and actually change out the module. The other problem with the thing was the size of the cap was enormous. So now you had space issues on some engines because it was just so big. The final issue that we brought up is the complexity of it being everything's together. To get to the pickup on Chrysler's, it was on the side. Well, on General Motors, it was underneath. So to get to it, you had to take the entire distributor apart carefully because there was a pressed-in bushing that if it came out, the distributor was now junk. And so that made it a little more complicated. But most of the times, there was really no issues with that. Mainly the modules went bad. Even the coils lasted pretty long just because they were up high and it heat sinking on them. Now, the thing with the system is that because it was compact, and this is how they got better power, they were able to set the dwell, which is the amount of time that the contact is happening to actually build power and disperse it. And it was actually variable. So at low RPMs, the dwell was like 15 degrees. Then at high RPMs, it went to 30, which is opposite of the way points work and actually the Chrysler ignition system, because they could not change the dwell. And actually, as you went faster, the dwell got less because of the rotation. So this is why this system really became the template for modern ignition systems. And that's why you can use an HEI with an MSD, because it is already built in to be able to dispense high amounts of power in a small package, and you have the modules inside to change out and actually make it so it can be modernized. It's an incredibly advanced system. And this is one of the few things General Motors really got right. And this system was so good that they used it all the way through the 80s with their computer system and had minimal issues with it. It was finally replaced by coil packs in the late 80s. But to this day, though, this is basically the aftermarket ignition system that is used by a lot of people, especially that do racing. It is used by them because of the compact size of it and that it is tailored to the engine due to different modules. So, I hope you got something from this, because it's kind of fascinating the way that two companies went about trying to meet emissions. And one made it too complex too fast and it didn't fail. One just went real simple and ended up stumbling upon a incredibly scalable system that has been used ever since. And all this came out of the horrible Malaise era where the government, overstepped their bounds by telling car manufacturers how to build cars. And, it's just absolutely kind of amazing that the simpler and scalable solution actually won out over the, more complex and, over-engineered system that was now just remembered as junk. So once again, I hope you got some of this. Please comment below. And if you got anything from it, hit the like. If you like car stuff, subscribe, because, well, if you subscribe to my channel, you'll get other car content, because that's the way YouTube works. And also, you can help me out, please. I want to get to 10,000 subscribers, and just hitting that doesn't cost you anything. Doesn't make, you're not gonna get junk mail. You're not gonna get spam. You're just gonna help me grow my channel so I can do more stuff like this and be able to share my love of cars with more people, because I love cars. Oh God, it's actually a sickness. So if you have something fun, or something cool, I guess, or something fun, take them out, because you'll make someone's day, and it will probably be your own. And I'll catch you very soon. Bye.